Hi students, in our last lecture we have discussed about trigonometric ratios for specific angles. Now I am going to discuss about trigonometric ratios of complementary angles. So first of all we should understand what is meant by complementary. Okay, complementary angles. Let us take a right angle triangle. Let us take a right angle triangle ABC. ABC, okay, right angle at B. We know that sum of three angles is 180. We have angle A, angle C and angle B. This is fixed angle, okay. If sum of two angles is 90, we can say that the two angles are called as complementary angles, okay. Let us take A plus C is equals to 90, angle A plus angle C is equals to 90, then you can say that angle A and angle C are complementary. Okay. If we have one angle, we can find out the another angle. Suppose here the two angles we can write like this, angle A and another angle will be 90 minus angle A. We can write like that. Why? Because if it is angle A, this thing you can write as, this particular C you can write as 90 minus angle A. Why? Because sum of these two we must and should get 90 degrees. Okay, that is about small introduction of complementary angles. One more word is there, which is a supplementary angle. Sum of two angles is 180, then we can call it as supplementary angles. Okay. Now we will fix angle A at vertex A and let us write the ratios of this particular thing. We can write sin A, which is side opposite to angle A divided by hypotenuse. So we will get here BC by hypotenuse is AC, and cos A also we can write, which is side adjacent to angle A is AB divided by hypotenuse AC, and we can write one more thing, tan A also, tan A, which is equals to side opposite to angle A by adjacent to angle A. So we will get BC by AB. Okay. Then we can write here cosecant A, which is AC by BC, because it is inverse of sine. Then secant A, which is inverse of cos. So we will get here AC by AB. Then next thing, cotangent A, which is inverse of tan, AB by BC. Okay. Now what I will do here, I will write the same thing based on this particular angle, angle C at C, by using C. Yeah. Now I will write based on C, sin C. Actually C is nothing but 90 minus A, we can write here. C, instead of C we can write 90 minus A. Okay. So sin 90 minus angle A, we can write here opposite to 90 minus A by hypotenuse AB by AC. So we will get here AB by AC. Next thing, cos 90 minus A, which is adjacent to 90 minus A by hypotenuse, which is BC by AC. Next thing, tan 90 minus A, which is opposite by adjacent. Opposite is AB, adjacent is BC to this particular angle. Okay. So we will write here AB by BC. Like that we can write for our cosecant A, cosecant 90 minus A, which is cosecant 90 minus A, which is inverse of sin 90 minus A, AC by AB, and secant 90 minus A, which is AC by BC, and cotangent 90 minus A, which is BC by AB. So, what we can compare here from these two? If we compare, we will understand one thing. If we compare these two things, these two sets, particular sets, you see sin A is equals to BC by AC, which is here BC by AC, which is cos 90 minus A. Okay, cos A is equals to AB by AC. So, we have this fraction over here. These two are equal. So, from that what we can write actually? We can write here from this one and this one sin 90 minus angle A, which is equals to cos A. Okay. Next thing, cos 90 minus angle A from the set. Where is cos 90 minus angle A? Yes, from this one and from this one. You see this BC by AC is equal in both the things. So, cos 90 minus A we can write as sin A. Then let us tan 90 minus angle A. See tan 90 minus A, which is equals to AB by BC. So, where we are having tan 90 minus A, AB by BC. Here we are having AB by BC. So, we can write here cotangent A. Tan 90 minus A is cot A. In the same way, we can write here cosecant 90 minus angle A, which is equals to, you see here cosecant 90 minus A is AC by AB. Cosecant 90 minus A is AC by AB, which is equals to secant 90 minus A, AC by AB. Here these fractions are equal. So, cosecant 90 minus A we can write as secant A, and secant 90 minus A we can write as secant 90 minus A is AC by BC, which is cosecant A. So, we can write here cosecant A, and the last thing cot 90 minus A, which is equals to cot 90 minus A, which is equals to, here you see BC by AB we are having, cot 90 minus A we are having BC by AB, which is actually equals to tan A. So, we can write here tan A, and these are our very important formulas. Sin 90 minus A, cos 90 minus A, tan 90 minus A, cot 90 minus A, secant 90 minus A, cosecant 90 minus A, all these are our formulas. We should memorize them. Okay, after memorizing the particular formulas, we can move to the exercise 8.3. Okay. Yes, we have exercise 8.3. First question, evaluate this one. Let us copy first question. sine 18 divided by cos 72. Okay, you see, while we are going to solve this particular questions, actually I don't know sine 18 value and cos 72 value. So what I should do? I need to check whether these two angles are complementary or not, 18 and 72. If I add the two angles, if I add, so what I will get, if I add 18 plus 72, I will get 90. So I can say that these two are complementary. So instead of sine 18, I can write cos 90 minus 18, which is cos 72. So I will change this one a little bit, either numerator or denominator. I will change here a little bit and I will solve. Yes, this sine 18 I can write as sine, instead of 18 I will write 90 minus 72 divided by cos 72. I have one formula, that is sine 90 minus A, angle A, which is equals to cos A. So instead of A we have 72 here, so we will get here cos 72 divided by cos 72. We have in the both numerator and denominator same factor, so we can cancel these two. Okay, yes, like that. Let us solve the second one. Let us change the color first of all. Yeah, I took blue, green. Second question is tan 26 by cot 64. Tan 26 divided by cot 64. Here also 26 plus 64 will get a 90. So these two, 26 and 64, are complementary angles. So we can use trigonometric ratios for complementary angles. So I will change either numerator or denominator. I will change, I will prefer to change the numerator. Tan 90 minus 64 we can write, divided by cot 64. We have one formula here, tan 90 minus A, which is equals to cot A. So we will get here cot 64 divided by cot 64. Okay. Yes, we can cancel this thing. So here I forgot to write one. So what we'll get here finally? 1. Next question. Yes, what's our next question? Third one, cos 48 minus sin 42. Third one. Third question, cos 48 minus sin 42. Actually I don't know what is cos 48 value. I know only 0, 30, 45, 60 and 90, but I don't know how to calculate this one. So what I will do, I will try to see the logic here. 48 plus 42 will get 90. So these two are complementary angles. So what I will do here, I will try to change any one of these particular term. Okay. Now I will change here this thing, cos 48 as it is I will write, this sin 42 I will write as sin 90 minus 42, 48. Why? Because 90 minus 48 is 42. So that I will get cos 48 minus cos 48, a minus a. So we will get here 0. Which formula we used here? Sin 90 minus a, which is equals to cos a. this is the formula which we used here. Okay, let us move to question number 4. Question 4 is cosecant 31. Cosecant 31 minus secant 59. Again, here also you see 31 and 59, these two are complementary angles. So we can write here cosecant 31 as it is, I will write, minus secant, yeah, that's not writing, one sec, yeah, we can write here secant 90 minus 31. So we'll get here cosecant 31 minus secant 90 minus a, which is again cosecant 31. So which formula we are using? Secant 90 minus a, which is equals to cosec a. So this is the formula which we used here. We will get here finally 0. Like that we will try to solve the questions by using complementary angles. Let us move to next question. Question number 3. If tan 2a is equals to cot a minus 18, where 2a is an acute angle is nothing but which is less than 90 but greater than 0. Find the value of a. They did not give the angle and they gave a statement, trigonometric statement. We need to find out the solution for that. So what they gave, let us copy that one as it is. Solution, tan 2a which is equals to cot a minus 18. Okay, now I will write, instead of this tan, I will change this one a little bit. I can write this one as cotangent 90 minus 2a, which is equals to cot a minus 18. So from where I got this one, I have a formula, cot 90 minus some theta or some any angle, cot 90 minus theta is equals to tan theta. If I have this one, I can write this one. If I have this one, I can write this one. So I have now, initially in the question they have given tan theta, so I can write now cot 90 minus theta. Now I can remove the cot both sides, then the remaining is 90 minus 2a, which is equals to a minus 18. Let us isolate the particular a and the constants. 90, if we send this minus 18 this side, we will get plus 18, which is equals to, if we send this to a that side, RHS side, we will get a plus 2a. So we will get 108 equals to 3a. Send this 3 left hand side, or else divide both side with the 3. Divide both sides with 3. So we will get 108 divided by 3 equals to a. From this I can write a is equals to 108 by 3, 3 ones, 3 3s 9, 1 will be left, 3 6s. So the value of a is 30 6. The value of A is 36. Oh, it's not moving. A is equals to 108 divided by 3. 3 ones, 3 3s 9, 18, 3 6s. The angle A value is 36 degrees. Like that we will find out the solution. Let's move to next question. If tan A is equals to cot B, then prove that A plus B is equals to 90. So what they give, let us copy that. Tan A is equals to cot B. Okay, this tan A we can write as cot 90 minus A, which is our formula actually, cot B. Now we can remove both sides, the cot, then we will be left with 90 minus A is equals to B. Send the A to another side, 90 is equals to A plus B. This is what we wanted to prove. We will write hence proved. Okay, let's move to next question. Yeah, here also we wanted to find out the value of A. Let us change the color. Yeah, yeah, they give secant 4A, which is equals to cosecant A minus 20. So we have a formula, cosecant 90 minus some theta, which is equals to secant theta. So we have, suppose here secant theta, we can write this cosecant theta. In the place of theta we can take 4A. So we will get here cosecant 90 minus 4A, which is equals to cosecant A minus 20. Now we can remove both sides, the cosecant, one second, we can remove the both side, the cosecant, then we will be left with 90 minus 4A, which is equals to A minus 20. Send the numbers to one side and the constants to variables to another side. So we will get A plus 4A, which is equals to 90 plus 20. 5A is equals to 110. A is equals to 110 divided by 5. 5 ones, 5 twos 10, 5 twos 10. So angle A is 22 degrees. Like that we will find out the solution. Okay, let's move to next question. Yeah, very important question. This question have repeated in our board exam many times. If ABC are interior angles of a triangle, then show that sine of B plus C by 2 is equals to cos A by 2. So what they gave, let us copy this one as it is. They have given A comma B comma C are interior angles of triangle ABC. So if we take a triangle ABC, these things are angles. They are saying like that. If those are the angles, then by what I can write, by angle sum property. Angle sum property, I can write here sum of all angles in a triangle is 180 A plus B plus C is equals to 180 degrees. You see, we have separately B plus C. I will keep this B plus C the left hand side only, and I will transpose this A to another side. So, B plus C is equals to 180 minus A. Now, left hand side I have sine. Let me take here both sides sine of B plus C, which is equals to sine of, yeah, one second, 180 minus A. Okay, we want B plus C by 2, so divide both side with 2, so that we will get 90 minus A divided by 2. Okay, now take both sides sine B plus C by 2, which is equals to sine 90 minus A by 2. We have one formula, that is sine 90 minus theta, which is equals to cos theta. In the place of theta we have here A by 2. So, our answer sine B plus C by 2, which is equals to cos A by 2. Okay, and that is this one we wanted to prove. This is our final answer. Okay, let's move to next question. Express sine 67 plus cos 75 in terms of trigonometric ratios of angles between 0 to 45. Here they are asking you should represent this angle in between 0 to 45, that's it. Okay, so what they given, I am writing sine 67 plus cos 75 degrees. I have a formula, cos 90 minus A I can write as sin A, sin 90 minus A I can write as cos A. You see 67's complementary angle, just subtract 90 minus 67, 10 minus 7 is 3, 8 minus 6 is 2, 23. So, what I will write here? I will write this, I will rewrite this one as sin 90 minus 23. So, what I am doing, instead of 67 I am writing 90 minus 23, this 75 also cos 90 minus 15. Why? Because 75 and 15 are complementary angles. Now, I can use this two laws. Sin 90 minus A is cos A. I will get here cos 23 degrees plus sin 15 degrees. Now, all these angles are in between 0 and 45. That's it. If you like the subject, please subscribe and share my channel. Thank you very much.